Hello, and welcome to the Current Science and Technology podcast from the Museum of Science in Boston. I'm your host, Susan Heilman, and every week we bring you interviews with guest researchers and our museum staff covering science and technology in depth. Hello, and welcome to the Current Science and Technology team's Top 10 Science Stories of 2013. These are some of the stories that we consider to be the most important and exciting and even just interesting science stories of the past year. And here with me today, we have
Corrine Tate,
Julia Sable,
and Sean Fankhauser.
So as we evaluate all these stories, we sometimes have trouble narrowing it down to just 10. So usually we have a few that are kind of on the fringes, and we have also awarded an honorable mention. Sean, do you want to tell us about that?
I sure do. So earlier this summer, a researcher from the Netherlands grew meat in the lab, then cooked it and ate it. So this was really a proof of concept type of research experiment, just proving that meat can be grown in the lab and be edible, I suppose. Although reportedly, it tasted close to meat.
So what does that mean, growing meat in a lab?
So they took stem cells from the muscle tissue of a cow, they plated it on petri dishes, and they grew up very small strips. It took 20,000 of these strips to make one 5-ounce hamburger. So then they combined that all together, put in the typical ingredients that you put in for your hamburger, some breadcrumbs, some seasonings, things like that. Cooked it up, served it up to some professionals in the food industry and the researcher himself, and the results where it was edible, tasted close to meat. Probably one of the reasons it didn't taste perfectly like meat was that they didn't have fat cells in there at all. So that probably detracted from the taste a little bit.
Although it might have made it a little healthier.
That's true. Speaking of carnivore, Susan, I hear you have another interesting story for our number 10 choice.
That's right. And this one really isn't done justice on a podcast. You really have to see the pictures on this one. The first new carnivorous mammal discovered in the Americas in 35 years was described earlier this year. It's called the olinguito. It's from the rainforests of Ecuador and Colombia. And to describe the way it looks, it's a cross between a house cat and a teddy bear. So I highly recommend all of you quickly Google that and see what this really cute little animal looks like.
So how is it that no one had seen the olinguito before? How was it not discovered?
So, in fact, it has been technically discovered before. We've known about the existence of this type of animal for a while. They just thought it was a different animal. They thought it was something called an olingo. Both of these animals, the olingos and the olinguitos, are closely related to raccoons. However, all of the specimens of skulls, furs, and even live animals were mislabeled as being the olingo.
Oh, okay. So it's not like this was an exceptionally rare species where there's only a few around. It was just kind of a mistake that was corrected.
Exactly. So we don't believe olinguitos are endangered at all. As soon as they realized it was a different animal, they went out to search for one in the wild, and they found one within a couple days. They live very high up in canopies of the rainforest in South America, and so it's not like people see them all the time, but there's lots of them up there, just higher up than they would normally look.
So transitioning to number 9, Julia, you're going to tell us about some technologies that affect our lives?
Yes, or at least they will affect our lives very soon. This year, there was a news story that someone in San Diego got pulled over for speeding, but the officer didn't just give her a speeding ticket, he also gave her a citation for wearing Google Glass.
So I've heard of Google Glass, but what exactly is it, and how can you drive with it?
It looks like kind of like a glasses frame, and then on one side it has a battery and an earbud and a camera and a little bitty screen in front of your right eye that lets you see things so you can look at the real world in front of you, but you can superimpose information that's relevant to that. It's a form of what's called augmented reality, and there's apps coming out for that on, phones and tablets, and it should get bigger and bigger. But right now, only about 10,000 people in the United States have Google Glass. It's still in beta testing, so you can't go buy one yet. But it sounds like it can replace the functions of a cell phone. You speak to it to give it commands, and you can have it call your friends and take pictures and look up stuff for you, and it's hands-free.
Well, because it's hands-free, that should be something that maybe is okay to use in a car.
Yeah, I think in a lot of states it would fit the hands-free laws, but in California there's a law that doesn't allow you to have any kind of video screen in front of the driver. So that tiny little screen near her right eye is sort of like a video screen. The problem was that she said that she wasn't using the Google Glass at the time. It was on her face, but it wasn't active. So as we increase our use of augmented reality and wearable technologies, we might see more stories like this where we have to work out how are we going to enforce traffic laws or other rules? How is wearable technology compatible with that?
So, Julia, this sounds like another instance where policy hasn't quite caught up to the technological advances that we're all being exposed to.
Okay, let's move to number 8. Sean.
Our number 8 story is about climate. So the Intergovernmental Panel on Climate Change, the IPCC, put out another report this year. And kind of the bottom line on this report is that climate scientists are at a greater consensus that climate change is happening and being caused by humans. They updated some of the projections for sea level rise and temperature change over the next century as well. A couple of other interesting climate stories this year. We hit a milestone as far as carbon dioxide concentrations in the atmosphere. For the first time in hundreds of thousands, if not millions of years, the concentration of carbon dioxide in the atmosphere hit 400 parts per million. And also on the carbon dioxide front, carbon dioxide emissions are projected to hit an all-time high this year of 39 billion metric tons.
Well, I guess not a record we necessarily wanted to break. So on a more positive note, Julia, why don't you tell us a little bit about our number 7 story?
Our number 7 story starts with a research team based at the University of Pennsylvania and Children's Hospital of Philadelphia. They have seen amazing success this year in a clinical trial to treat leukemia using HIV as a tool.
Using HIV as a tool to fight disease?
Yes, so leukemia is a category of cancers of the blood and bone marrow. The one that they were working with happens to be the most common cancer in children, and they had both adult and children participants in the clinical trial. The problem with this type of leukemia is that one type of immune cells is malfunctioning. So they took a different type of immune cells out of the patients and re-engineered these cells to be able to attack the malfunctioning immune cells. And to re-engineer them, they had to use something that would insert new genetic material into those immune cells. And HIV was their tool for that. But it wasn't plain old HIV, the virus that causes AIDS. They removed the genetic material that makes it dangerous, and they inserted this genetic material that they want to add to the immune cells. And they chose HIV because that virus has a structure that makes it really good at latching on to that type of immune cells and inserting the genetic material in there. So that's why it made such a good tool to reprogram those immune cells.
So the genetic material that's inserted, what does it do?
It modifies those immune cells so that they target the type of cell that happens to be malfunctioning in this kind of leukemia. They put the reprogrammed immune cells back in the patient, and it totally succeeded. For most of the participants in the trial, those cells killed the cancerous cells. Unfortunately, they also killed healthy versions of that type of cell, which means that these patients' immune systems are depressed in a way. But most of the patients are cancer-free.
Well, Julia, that is really good news. So now let's move on to our next story. Kareen, what do you have for us?
Our number 6 story has to do with some breakthroughs in nanoscale imaging. You probably remember chemistry class, those little stick drawings of molecules you had to memorize and figure out how to draw. Well, your chemistry teacher was right. They actually look like that. Researchers at Lawrence Berkeley National Labs made big headlines this past year for imaging for the first time the making and breaking of molecular bonds during a reaction.
So they were actually able to see this happening? How could they do that?
So they used a tool called an atomic force microscope that has incredible resolution, below even a single nanometer. And we'd previously used tools like that to see individual atoms. But never before had we been able to actually image the bonds, the shared electrons between atoms. So it was a really big deal. And they stumbled across it by accident. They weren't trying to image this chemical reaction. They were actually trying to make sheets of a material called graphene, which is an atomically thin single layer of carbon atoms. And they weren't being successful. So they decided to use a really high-powered microscope to figure out what was going wrong. But they were just amazed and surprised to actually be able to image the individual bonds as this chemical reaction was happening.
So when you say that we're able to see bonds, you don't mean like see with light. It sounds like the phrase atomic force microscope makes it sound like it's detecting it with force.
You're right. So an atomic force microscope doesn't use light. It actually has a very sharp and sensitive tip that scans across a very smooth surface, in this case of silver atoms. And on top of that are the molecules that we're trying to image. And as it scans across, it's sensing the forces of the atom. It's sensing those forces, and in the case of the bonds, it's actually so sensitive it can sense the force of just the electrons that are being shared between those two atoms.
Very cool story. Now, staying on the same kind of scale, we're going to move to our number 5 story of the year, and Susan has all the information about that one.
So earlier this year, scientists at University of Massachusetts in Worcester, in fact, my alma mater and one of my former professors, figured out a way to be able to silence the 3rd copy of the 21st chromosome in Down syndrome individuals.
How did these researchers accomplish such an incredible task?
They took a gene that's present in the X chromosome, and in females have 2 X chromosomes, males have an X and a Y. Well, in females, that second X chromosome is silenced. None of the DNA on it is actually expressed. It's there, but nothing happens with it. Well, they took the gene responsible for that and put it into one of the extra copies of the 21st chromosome. They used cells from an individual that had Down syndrome. So this was done in a dish, though, not in an actual person. And they saw after just a couple days that the 3rd copy of chromosome 21 was silenced. Basically, they saw normal expression levels of all the different genes that are present on the 21st chromosome instead of seeing that extra amount that was caused by the presence of an extra chromosome.
So they used one gene to affect the expression of a whole chromosome full of genes.
Exactly. Some people might call it chromosomal therapy, but technically it's gene therapy. One new gene put in, and the effects are just amazing by silencing a whole chromosome.
So what does this mean for people with Down syndrome? Are they trying to prevent it from happening altogether?
So the goal of this project is not necessarily to use this procedure in people that have Down syndrome. Even though this is the most common genetic abnormality in humans, it's still not really well understood because it affects an entire chromosome with hundreds of genes on it. And so this new breakthrough is going to be really important to use as a tool to understanding the effects of this, the causes of these characteristics, and how the dangerous ones, like things like congenital heart defects that occur in more than half of all individuals with Down syndrome, how they can mitigate those effects.
That sounds like really interesting and promising work, Susan. Julia, I understand you have our number 4 story?
Our number 4 involves 2 space rocks that got a lot of attention in February 2013. One of them was an asteroid 150 feet across, so half the size of a football field, that moved between Earth and the Moon, which is rare. So as that was flying by, which was completely harmless, it just went past Earth. As that happened, a different meteor tore through the sky over Russia and left like a trail of fire, and it exploded in the sky.
Was anyone hurt with that? That seems really impressive.
It was impressive. A lot of people caught the meteor on video. And they saw the trail of this meteor and all its fragments as it broke apart. So those fragments of the meteor did hit the ground. So whatever they hit caused some damage, but most of the damage came from a shock wave from the meteor when it was exploding in the air. A few seconds later, this shock wave blew out windows and knocked things down. And the video ended up being scientifically useful too. Scientists took as many videos as they could find and calibrated them to trace the meteor's exact path. And they traced it all the way out into space and saw that its trajectory matched another meteor from the past, and they might have both been pieces of the same space rock long ago.
Thankfully, no one was killed in this, and hopefully we can even learn more information about meteors in general. And unfortunately, speaking of natural disasters, one just occurred that we recently added on to our top 10 list because of the impressiveness of it. Sean, do you want to tell us about that?
Sure. So our number 3 science story of 2013 has to do with the super typhoon that went through the Philippines in early November.
What makes it a super typhoon?
So first of all, a typhoon is just like a hurricane. It's just called something different because it's in the Western Pacific Ocean. And super means that it has winds of 150 miles per hour or greater. But in this case, it was much greater. It had winds estimated just hours before it made landfall in the Philippines of 195 miles per hour. Now, a lot of analysis has to be done on this particular typhoon, but it may have been the strongest tropical cyclone, which is a typhoon or a hurricane, that made landfall at that particular strength. No other hurricane or typhoon has been that strong as its eye, the center of circulation, went over land. But again, a lot of analysis has to be done to figure out if that was exactly true or not. The bottom line, it was an extremely destructive typhoon. From the winds, almost no structure can withstand 195 mile per hour winds. There were some concrete structures that did, but it just wiped out almost everything, especially in Tacloban City, which is where we've been seeing a lot of images coming from.
But I even saw things like ships washed up inland. How did that was there that much rainfall?
So there are 2 threats with water as far as super typhoons are concerned. Number 1 is from above, the very heavy rainfall, which can cause flooding. But number 2 is really the bigger concern, especially in these areas that really don't have a lot of elevation that we've been seeing a lot of destruction in. And those are the areas that really suffered when the storm surge came in. And that's that temporary sea level rise that accompanies a typhoon or a hurricane. And it's estimated that it was 15 to 20 feet in some cases here, which can float almost any ship, a lot of ships, big, heavy ones, take them inland and deposit them on people's homes. The people of the Philippines will certainly have a long road ahead of them as far as their recovery is concerned. Now it's time to turn to our number 2 story of the year. Kareen, what do you have for us?
Well, a little bit closer to home, some really big news in October was the government shutdown. It was huge political news, but actually it made our top 10 list because it had a really significant and potentially long-lasting impact on science.
What kind of effects did it have?
During the 16-day shutdown, a lot of the news was focused on the fact that the staff of the government was furloughed and couldn't come to work. So obviously federally funded researchers were affected. But beyond that, a bigger cost was that they couldn't actually do their research. And many of them are left with critical and large gaps in their data.
A lot of research can be time sensitive. You can't just leave it unattended for days.
Exactly, especially longitudinal studies. Scientists who are funded by the government also couldn't present at meetings, and that was significant for several international policy meetings where there ended up being no American representation at all. The furloughed staff also couldn't perform a lot of safety inspections and monitoring programs at institutions like the FDA and the CDC. Unfortunately, the beginning of October is the start of flu season. So
that's exactly when you want to be able to track flu outbreaks.
exactly, with 2/3 of the CDC staff on furlough, they weren't able to track some of these critical outbreaks. And beyond just seeing what's happening this season, it's really important for the staff to understand what strains are coming up because that influences the development of next year's flu vaccine.
And what about the space program? We've got humans on the International Space Station, and I know other countries are involved, but did we ignore them?
Actually, 97% of NASA's staff was furloughed. So they had only a skeleton crew to maintain the safety of the astronauts that are on the International Space Station.
Well, Corrine, that was a pretty big and nasty number 2 news story.
How about we switch from sort of a disappointing moment for the U.S. to a really triumphant one for number 1, Susan.
And our number 1 science story of 2013 is, drumroll, Voyager has left the solar system. In 1977, Voyager 1 and Voyager 2 spacecrafts were launched from Earth with the missions to study the outer planets, Jupiter, Saturn, Uranus, and Neptune. Well, after they were done with those missions, there was some power left, satellites were still working, let's have them keep going. Now, 36 years after their initial launch, Voyager 1 has officially left the solar system.
Well, didn't it leave the solar system when it passed by Neptune?
Very good question. So some people might associate that with leaving the solar system. There's actually a lot of different ways to look at it, basically looking at different zones of influence that the sun has. So solar system having to do with the sun. Now you can look at the gravitational effects of the sun. You can look at the electromagnetic effects of the sun. You can look at supercharged particles coming from the sun. And wherever you have a certain limit of those things, that's where you could say it left the solar system. So there doesn't seem to be a hard and fast line, like all of a sudden one day it stops being a part of the electromagnetic zone of influence of the sun. But what they're seeing now is electromagnetic effects and charged particles from other things in the galaxy, more so than they're seeing those effects from the sun, which technically means that Voyager 1 is in interstellar space.
So you're telling me that Voyager is still sending us data?
I think that's one of the really cool aspects of this is not just how far Voyager's gotten, but the fact that we're still receiving data from a 36-year-old piece of equipment. So it still has, many of its systems are still functioning. Same with on Voyager 2. It just hasn't gotten out quite as far. And even though it takes 17 hours or so to get a signal from Voyager, we're still getting one.
So is Voyager just going to keep going and going and going? Does it have Energizer batteries on it? Is there a limit to how far it can go?
So that's kind of two questions. One, Voyager, unless it hits something and breaks apart, can technically keep going and going and going. However, the power is a different story. There's enough power for all systems to function until 2020, and then they're going to begin to power down various systems until in 2025. They don't believe they'll have any power left for any of the systems on there. But there's nothing to say that it won't keep on going with carrying that golden record of music and sounds from Earth out into the beyond, and will continue to be the most distant man-made object.
That was a far out story to end our top 10 science stories of 2013. I'm looking forward to what 2014 has in store for us.
Happy New Year! That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.